Well, I'm going to be talking about managing pollen drift to minimize contamination of non-GMO corn. I gave a very similar talk to this a couple of weeks ago at the OFA conference. Anybody know what OFA stands for? Is anybody here an organic corn producer or interested in growing organic corn? Good. I mean, you haven't seen it before. But OFA is the Ohio Ecological Food and Farm Association, and they wanted to address this very similar subject to this one. So, interest in pollen drift, it's always been a major concern in the production of hybrid corn seed. When you buy a bag of corn seed, it's pretty expensive now, but you want to ensure that it has high purity. And so it's been a very concern of theirs. If you go to seed corn companies, their livelihood and their reputations are dictated by purity. Another area of why there's interest in pollen drift is specialty corns. By specialty corns, I'm talking about corns like white corn, food-grade corn. I worked many years on high-oil corn. And if high-oil corn was pollinated by normal dent corn, instead of having a grain oil content of, say, 7%, it might be reduced to as much as 5%, down to 5%. Normal corn, say, 3.5% to 4%. So in order to optimize expression of value-added traits like high-oil corn, the absence of yellow kernels in white corn, you have to have an interest in pollen drift. And there's another reason. I saw this truck outside a Whole Foods in Dublin, Ohio, and it has some interesting paintings on it, some graffiti-type paintings, and I don't speak Spanish. I looked these up, and in the upper left-hand corner it says "Mothers create peace, women create peace." I think. It's got a little emblem there. It says it's a cross between GMO and Terminator seed. Down here it says, it's got a little emblem there. Yeah, you saw that one. Then it's got two of our seed companies which sponsor this meeting, and they are involved, I think, one of them at least. Okay, that's right. I think they were prescient. They knew it was coming down the road, evidently. So they say that one equals Myrte. Anybody idea know what Myrte means?
I guess murder.
Death. Very, very close. So, this is a passionate subject. These folks are not, to be... this is a market. These are consumers that we have to be concerned about. We want to, I want to say we necessarily want to accommodate them, but these are people who are very concerned. And what's that?
They're great artists.
Well, I think I'm glad you said that, because you notice the ears of corn. What's inside those ears of corn? If you can tell me what's inside those ears of corn, and you're in the back there, then I think the small screen will work for us. What are those? They're skulls instead of kernels. So, maybe that's something I won't use in any of my graphics, but, it does get your attention. But so this is this is a subject we're concerned about. So it's become an important consideration in the production of organic, but also just non-GMO corn as an identity-preserved crop. Producers of IP, identity-preserved, non-GMO grain, are concerned that pollen drift from GMO corns will contaminate nearby non-GMO corns. And today when I refer to GMO, it's the same thing as transgenic. And when I talk about, so non-GMO is non-transgenic. I'll go back and forth probably, forget to use one consistently. So what is the tolerance level for non-GMO corn? We hear a lot about non-GMO corn. What's the tolerance level for it? Anybody know? Is it 2%, 5%, 1%? Any other thoughts? 3%? And when you say to 1% or 3%, where did you hear that number? From who? From a grower. So maybe that grower was using it in the context of he was growing it for a particular end user that specified that. Do you know if there's a government? Anybody heard a government standard for it? Well, let me go back here. The overseas markets for non-GMO corn have rigorous restrictions. Japan has a zero tolerance level for seed and food imports containing unapproved GMO material. The zero tolerance. Now, food products containing less than 5% of approved biotech crops like corn and soybeans can be labeled as non-GMO. The European Union guidelines require that grains containing more than 0.9% biotech GMO material be labeled as genetically modified. That's the European Union. So what do we have here in the U.S.? We have no official standard in the U.S. Now, the numbers you're throwing out at me, they're not incorrect. It's because the end users establish what the guidelines are in this country. But that has some interesting implications. So we have no threshold for GMO corn. I suspect the same is true for soybeans, because we're talking biotech material. Organic corn production specifies use of non-GMO corn seed and practices for producing organic corn, but we have no guidelines on what's minimum requirement. And I assure you, some contamination is always possible. You know, that's unfortunately. I'm not here advocating tolerance levels or anything like that. This is basically more of a marketing issue than an agronomic one. So these labels, I'm sure a lot of you have seen the USDA or seen the USA organic label. And what does it specify? Well, it's telling you that the product has been grown using organic practices. And one of those is using non-GMO corn hybrids. Do they use non-GMO hybrids? Well, I think a lot of the growers nowadays are using non-GMO corn, but there are loopholes in it. If you're an organic farmer and you can argue or you can petition that you need to use a non-GMO commercially available hybrid because the hybrid you're looking for, a particular maturity, maybe disease package, doesn't exist. So you can petition the USDA organic program and say, I need to use a particular hybrid. I want to use a non-GMO version of that hybrid. Well, it's non-GMO, and should you be allowed to use it? No, I have no problem with that, but there's some issues with that. Also, there's another project, and I think sometimes people get these two mixed up. There's one called the Non-GMO Project. Non-GMO Project Verified. And the Non-GMO Project Verified label ensures there's virtually no GMO ingredients in the product through an extensive testing verification product. But if you go into the literature, there's nothing to tell you what that virtually no GMO ingredients are. We don't know whether they're talking 1%, 0.5%. So it's kind of frustrating. So it's possible that you can have a product labeled non-GMO verified, and it's not been grown organically. And I assure you, there's corn out there that says it's USDA organic, and it's contaminated with transgenic with corn. So in this area, some of you, I suspect, in the audience may know more about this than I do. But if you go to the Danone website, and of course Danone created a stir several years ago. Was it about 2 or 3 years ago? Do you think?
It's been about 2 years now.
2 years ago? They decided to buy non-GMO corn, didn't they? And if you go to the Danone website, what's the Danone website say? Well, they've got something called the Danone Pledge. It says if it still has GMO ingredients, we'll let you know. And they've got labels like which you have on top of a yogurt container. It says non-GMO ingredients, and then one says partially produced with genetic engineering. So it has an interesting little blurb in there. It says we label all our products as partially produced with genetic engineering if they contain more than, we've seen this number before, 0.9% GMO ingredients. So this 0.9% is not official, but it's floating around out there. A lot of the companies are using it. And I've talked to food processing companies, and that's the one they use. It's not in black and white in any standards, official standards, but that's the one the end users are using. Why? Because it's the Europeans have established that. So if you've got a European market, Danone's obviously, is Danone an Italian company or French company? It's one of those. But so for all intents and purposes, I think 0.9 is the one that most people are using right now. And talking to some of the people at the OFA meeting who are involved with the National Organic Program, they're sort of saying that's a standard they'd like to see us adopt. Well, there's a lot of traits out there right now we have to be concerned about if you're into non-GMO production. This just shows you the trait sets and technology products we were working with in 2018 in the corn performance trial. We had 15 trait sets and 23 technology products. One thing that's interesting about this, that means that at the end of the season, you want to see if your corn has been contaminated. How many test strips do you think you'd have to buy of those little dipsticks? Well, there's another one out there. The previous one here, this is all related to corn borer or insect resistance or herbicide resistance. There's another transgenic product out there that kind of flies underneath the radar. It's Enogen corn, high amylase corn. It's transgenic. It was developed specifically for the ethanol industry. It expresses alpha amylase enzyme, the primary enzyme used in drying ethanol production. And instead of having the ethanol plant, instead of using liquid enzymes, they just use the grain. And once that grain is broken, subjected to water and the process, the heating process, the enzyme's released. It has some downsides because if it's planted near food-grade corn, it would cause that food-grade corn to turn to mush because it turns starch to sugar. A lot of the food industry, a lot of the millers in the country, the grocery store chains, when this first came out in 2012, were vehemently against it. But this certainly works very well in the ethanol industry, and up to this point, it's been primarily used in the neighborhood of the ethanol plant. They've used very good stewardship. It hasn't been a problem, at least to my knowledge. The downside, though, is that now Syngenta has recognized that Enogen corn is also has a lot of potential in silage production and as a livestock feed. So that means that if it could be used for silage, we might see it more spread around the state. So this is yet again another transgenic trait that we need to recognize and be prepared to control. Well, adoption of transgenic corn, we all know it's prevalent across the country. In the U.S. as a whole, the gray bars here indicate Ohio, the red bars indicate the U.S. In the U.S., we're 92% transgenic. Actually, Ohio is one of the few major states that has a fairly significant percentage of non-GMO corn, about 14-15% the last couple of years. And that translates into a fair amount of non-transgenic corn. That's not food grade, that's not necessarily corn that's organic. I think the organic would be a tiny fraction of that. It's corn that growers are simply growing non-transgenic conventionally. Most of those people are growing that corn to save costs on technology traits. And the transgenic entries and non-transgenic entries in our corn performance tests since 1996, when the transgenics were first introduced, were pretty much exclusively transgenic in our performance trial. In 2018, 183 of our entries were transgenic and only 9 were non-transgenic. There's more non-transgenics out there, but they're not typically looked at regularly in performance trials in Ohio or other states. Producers of non-GMO corn need to minimize pollen contamination by GMO corn to obtain premiums associated with identity preserved contracts. And as GMO acreage continues to increase, the potential contamination of non-GMO corn is increasing. So several factors contribute to contamination. Genetically impure seed lots. So right off the bat, if you plant a corn that, even if it's sold to you as non-GMO, you have to be cautious. Those impure seed lots can result from pollen drift during seed production, and they can result from mechanical mixing during seed handling. They can result from volunteer plants from a previous GMO crop, mechanical mixing of grain, and what I'm going to focus on today, pollen drift from adjacent fields. But let me go back to that one about genetically impure seed lots, because I'm responsible for the Ohio Corn Performance Test. And when Rich Menyo and Alan Geyer were checking our fields a couple of years ago at one of our locations, we noticed that we'd had a mix-up. Even though most of our corn, 90% or more of the corn, is transgenic, we treat it with conventional herbicides because we don't want to kill our non-GMO corn so they don't have herbicide resistance. Well, that's fine, but we had a mix-up one time, and the co-op sprayed Roundup. So what do you think happened to the non-GMO corn? It should have died. Well, we had a couple of plots out there, a couple of hybrids that were non-GMO. Well, we went in and looked at them. Probably 10 to 20% of the plants were still alive, and they were healthy plants. So the message I'm giving you here is that there's, when you buy a bag of non-GMO corn, it may contain some GMO seed. In fact, if you go to, I was looking down here among our exhibitors, and I've seen this in some other seed catalogs. Some of the seed companies actually will specify, if you're interested in non-GMO corn, this is one from, I don't want to give this one, this is Viking. They're not talking about organic corn here, but they've got 2 different grades. They've got 99% non-GMO corn, and they've got 99.9% GMO corn. So this is something to be aware of. So when you buy a product, and you have an end user who might be particularly finicky about what, and he's going to test, you might want to check to make sure you're getting a corn the seed company has made a special effort to limit foreign seed or transgenic seed. Because I assure you, there's companies out there that are marketed as non-GMO corn. They're not breaking any rules. But in some cases, there may have been more non-GMO, more GMO corn in that non-GMO corn than was expected. But I'm going to focus on pollen drift from adjacent GMO fields. So you need to be familiar with certain physical and biological characteristics of corn pollen. You need to know something about the potential distances that pollen can travel. And you need to know planting practices that are going to reduce the risk of drift, pollen drift. Now, this is just a picture of a corn tassel. You can see those really tiny pollen grains. They look very tiny, but within the grass family, corn produces one of the largest pollen grains. That's good news for us. It's good to hear. It's good that it's large because that means it doesn't really travel that far. It travels only short distances compared to other grass pollens. The challenging part, though, is that a corn tassel typically produces 2 to 5 million pollen grains over a 5 to 8 day period. And it can shed pollen for about a field can shed pollen for 10 to 14 days. Now, the good news is, well, not good news, but the facts are that the pollen is viable for only 1 to 2 hours under typical field conditions. High temperatures have a negative impact on pollen viability more than low humidity. And this is just a picture of a corn tassel. You can see the anthers emerging from the center of the central spike, and they're being released there. And this is just a close-up of a tassel showing you the anthers, and they're the structures that are kind of hanging from the flowers. And at the very end of those, there's like 2 little double barrels, little pores there. And late in the morning, when things start drying up, when it's wet, the pollen is not being shed, but late in the morning, when it starts drying, that pollen starts pouring out of those anthers. So what happens if pollen dispersal is not controlled? We get something known as the Zinnnia Effect. And this is the effect of cross-pollination effects on the chemical and physical composition of seed. Zinnia means foreign pollen, basically. Xenophobia, you've heard of that term using fear of foreigners. So Zinnia effects are readily evident when corn with different colors is grown in neighboring fields. And I suspect all of you have sometimes seen some scattered purple corn kernels in an ear of corn. We've seen this in our plots. A couple years ago when I was doing more work with specialty corns, I had a block one year of yellow dent corn next to a block of purple corn. And lo and behold, a classic example of Zinnia outcrossing. In the rows that were adjacent to one another, you can see the crossing that occurred. You see those purple kernels in the yellow dent corn ears, and you can see the yellow kernels in the purple corn ear. Now imagine that's the same thing that's happening. That's the outward appearance, the color of the kernel, but the same is true if we were talking about genes, like transgenic traits. This is kind of a marker. You could regard it as that. Yes?
So I had a grower. So that second ear from the left, just a few scattered blacks in there.
Yeah. That's right next to the other row.
So I had a grower who had a field of one of our hybrids. And he picked some of those ears, and I caught up with him in the fall. And he says, he's somewhat angry. He says, it came out of the bag this way. I says, was the whole field like that? Well, no. I said, well, then it couldn't come out of the bag. And I told him, I said, your neighbor must have had some Indian corn in the neighborhood. Was I right or was he right?
Was it refuge in a bag?
No.
Okay. One time I had a situation where I had a refuge in the bag corn, and the refuge seed had some funny colored corn in it. But the thing is, corn can travel great distances. Even a home garden, if you were next to somebody who had a big home garden and was growing Indian corn, you could have something like that happen. A very windy day, in the middle of, even though, as I'll get to it, middle of July, if we have really strong winds, certain times with some of these big rainstorms that come through the state, that can move a lot of pollen around. So I think it's possible. I always run it, every year we always run into a few scattered kernels on corn ears that are discolored. Some of these, the other thing is that sometimes it can even be genetics. There's some genetic mutants that are out there that aren't cleaned up in impurity situations. So that's another, I'm not a plant breeder, but I know that happens also. So I can't point towards the Zinnia effect being entirely responsible. I think there's some other things that can happen.
These are 4 adjacent rows?
No, there was probably 60 or 80 rows in here, and when we got these were adjacent to each other, and this is probably 50 feet apart. So by the time we got 50 feet away, it might have been 60 feet. We didn't see any evidence of that, or very little evidence of it. Now, so you're mentioning that purple corn, that enogen corn. What enogen does is when they tend, I think it's 5% of the seed in a bag of enogen corn is purple corn. And why would they do that? Why would they stick 5% of the corn in an enogen bag, the Hymalase corn, with purple corn in it? It's the stewardship thing. Yeah, you start seeing purple corn in your fields, there's a possibility some of that enogen corn got into your corn. So at the end of the growing season, 5%, in theory, 5% of your plant stand should be purple corn plants. And I'm not positive Enogen does that with every one of their Enogen hybrids, but if you go online, they mention that purple.
So I'm 55 years old, and when I was 10, we used to pick corn, and every once in a while we would get I'm thinking they were red. They were supposed to be like a special prize if you found the red.
Yeah. Mm-hmm.
What caused those red ones?
Well, it's different pigments. There's the anthocyanins, there's anthocene. These are pigments in corn. Actually, and there's something the organic people are actually trying to develop, because these pigments are being looked at for as natural dyes, and also in food grade corn. One of the things, kind of the holy grail for red corn, is red corn chips. They'd like to have red corn chips. They're looking for orange, but that's something they're trying to develop. But I've seen, again, with Indian corn or open pollinated corn, I have seen corns that look to me, I'm colorblind, but they look to me that they're very red. So theoretically, pollen grains can travel nearly a mile in about 6 minutes with a 10-mile-an-hour wind and remain viable enough to pollinate an adjacent field. That's theoretically. In reality, corn pollen settles at a rate of about 1 foot per second, so most of it won't travel that far. On a very calm day, most of a corn's pollen is going to land within feet of itself, not a quarter mile away. At a distance of 200 feet from a pollen source, the concentration of pollen averages only 1% compared to with the pollen samples collected about 3 feet away from the pollen source. So you're kind of getting the idea that this is a large pollen, a large grain that's falling pretty quickly. The number of outcrosses is reduced in half at a distance of 12 feet from a pollen source and at a distance of 40 to 50 feet. The number of outcrosses is reduced by 99%. We kind of saw that with that color corn, the purple corn. So this is good. This is on a very calm day, though. Well, so the risk of pollen contamination, it's influenced by pollen viability and the potential for pollen drift to adjacent fields. Pollen viability decreases with increasing desiccation, which is influenced by relative humidity, temperature, and time after release. Pollen drift is influenced by pollen settling rate, wind, physical barriers, and distance. Now, the research on this subject is limited. There's been obviously more of it now with the GMO corn. There's been more attention given to it. In the past, most of it focused on seed production fields. But there's been some studies, I think, since 2000, which some of these studies are very straightforward. There was one, a Colorado study, which I think is a nice kind of demonstrates some of these issues. And they looked at 2 studies to estimate pollen drift in hybrid fields. They looked at an experiment involving blue corn as a marker trait, and a trial using Roundup herbicide tolerance as a marker trait. So what they did, this was in Colorado. They planted a block of blue corn and surrounded it with yellow dent corn. And 10 ears per sampling site were harvested at distances of from 3 to 1,000 feet from that blue corn. And they noted that morning winds were mostly from the north and the northeast. And that's because, those winds are going to be a factor also, obviously. So what did they find? Well, this graph shows the percent cross-pollination versus distance for 4 directions from a blue corn source. And on the y-axis and the vertical axis there, you can see percent cross-pollination. And then on the y-axis, we've got everything. We start with 30 feet going out to almost 1,000 feet. And you can see we saw the greatest, because it's coming from the north, naturally we did see the greatest amount of pollen contamination in the southern part, in the southern yellow dent cornfield. And it was approaching about 2.25%, 30 feet away from that blue corn block. But within 150 feet of the blue corn block, the cross-pollination had dropped to 0.5% or less. Same type of study. Now they did it with Roundup Ready corn. They planted a strip of Roundup Ready corn 160 feet wide, and they had conventional corn on both sides of it. And again, they sampled corn ears at distances from 10 to close to 1,000 feet from that strip of Roundup Ready corn. And here again, when they were in one of those cornfields, we were looking at about 3.75% contamination when we were about 30 feet away. But by the time we were, by the time we were 60 feet away, it had dropped considerably. And by the time we were 150 feet of the Roundup Ready plot, the pollen drift, pollen contamination had dropped to 1% or less. In that study, the Colorado study, the furthest distance any cross-pollination was detected was 600 feet. Data suggests that, so this, I think that would indicate now that 150 feet may be a reasonable buffer between these transgenic GMO corns and non-GMO corn to prevent significant, and that's the key word there, cross-pollination due to pollen drifting from one field to another. But if you go into the scientific literature and you look at these studies, past studies have shown that cross-pollination could not be limited to 0.1% consistently, even with isolation distances of 1,640 feet. And this is why when they say, you look at a product on the market or on a grocery shelf and it says organic, GMO-free, it's awfully hard to establish. We can't say that for certain because of these distances. There's going to be trace amounts in there. And that's why, there's concern about, using transgenic corns in Mexico where there's the land races of corn that have been kind of preserved by the indigenous population that haven't been contaminated by GMOs, but there's a lot of scientists have expressed concerns that even if corn is grown several miles away, there's always that possibility that it could start contaminating some of these native corns, which are kind of a valuable source of germplasm for us.
And when they say it's 1% or 3%, do they figure that by weight, by visually looking at it? How?
They're doing this by visual. For the yellow dent corn, they were doing it by visual. And that one in Roundup, it was a grow-out test where they would take a certain number of kernels from those 10 ears, they'd shell the ears, and then they would do a grow-out test and spray it with Roundup. So let's move on to managing corn pollen drift. And I don't know, if some of you have been growing non-GMO corn. I'd be interested in hearing what you're using, or one of these techniques, or maybe a combination of several of these techniques. The methods currently used to minimize pollen contamination, monitoring, isolation distance, which we've already talked about from the standpoint of research, border rows, natural barriers, and differential flowering dates. Some people refer to this as temporal isolation versus isolation distance. So monitoring, this is kind of critical, especially in Ohio, where we have, in parts of Ohio where we have maybe smaller farm fields next to larger ones where there might be transgenic, and you have a smaller acreage of non-GMO corn. Which fields will be planted to GMO corns? What are the intended and eventually actual planting dates of the adjacent fields? And what are the maturity ratings, especially heat units to soaking, flowering? We're more concerned about that than we are to maturity. I don't really, in a cornfield, you're more concerned about when those two hybrids that are grown next to each other, when they're going to reach flowering. But this gets complicated because, in the last couple of years we've had wet years. A grower, your neighbor might say, well, I'm going to plant my corn really early. And you can say, well, I'll plant organic, or an organic grower might say, well, if you plant it really early, I'll plant mine after May 25th or 1st of June. Well, what happens? The rain prevents him from planting early, or he has to plant a second time. He has to replant. So he ends up planting the same time you do. So the best, everybody may have good intentions, but the weather can intrude on our plans. Well, the one I think probably the one there's most interest in using is to use isolation distance. And again, in Ohio, versus the western corn belt, you're not in Nebraska where you've got huge fields. You're in an area where you have smaller fields in many parts of Ohio. The isolation distance may not always be what we need, but this is where we separate or isolate non-GMO corn fields to limit exposure to the pollen of GMO fields. The potential for cross-pollination, as we've already seen, decreases the distance between GMO and non-GMO corn fields increase. And you've seen what the numbers are like, but what some state seed certification agencies say is that they offer identity preserved grain programs for corn, and they require that the non-GMO corn be planted at a distance of at least 660 feet away from any GMO corn. Is that what people do? Not a lot. A lot of people do this. They compromise. And the standards, the AOSCA Association, AOSCA, Association of Official Seed Certifying Agencies, allows this. The 660-foot isolation distance may be modified by removing varying numbers of border rows. Of course, you're losing yield there. You're losing some of that yield when you have border rows in your non-GMO corn. But this depends on the acreage of the non-GMO corn. So if you have a non-GMO field that's over 20 acres in size, the isolation distance of 660 feet may be modified by post-pollination removal of 16 border rows if the isolation distance is less than 165 feet, or 8 border rows if the isolation distance is between 165 and 660 feet. So there's some compromises there, and I think a lot of people do this because it's practical. They're willing to sacrifice some of that non-GMO corn. Now, if you're starting to get into things like white corn, high-O corn, you're taking a fairly big hit because those are corns that have pretty big premiums associated with them. So, what's that?
How do they isolate
Popcorn
popcorn?
is dense sterile. Yeah. Well, I shouldn't say that so categorically. Most of the popcorns that we grow under contract, my understanding is that they're not all this way, but most of the popular ones that we use are dense sterile. That's not true for sweet corn, but it is for popcorn. In other words, you could grow popcorn, a dense sterile popcorn, right next to a GMO field, and you wouldn't get contaminated.
I was wondering about that because I know I have producers
Yeah.
in work that have your popcorn right up against.
I'm sure you'll find that there's probably some heirloom popcorn varieties or some older ones that don't have that, but the newer traits, going back a number of years now, have been dense sterile. So you shouldn't have a problem with dent corn pollen affecting your popcorn. So another trait another method that might be beneficial for us is, because we have a lot of fields in parts of Ohio that are like this, is taking advantage of physical barriers. Looking for a field that might be bordered on two sides by woods. And that can be very effective in, say, in July when you get pollination. These woods can intercept a lot of pollen, dense woods. So they're usually good for gray leaf spot and northern corn leaf spot too, because they're nice and humid late in the season. But isolate non-GMO fields by planting at adjacent to woodlots to create physical barriers. And then there's the different flowering dates, and this is another popular one, but there's caveats with this one. So this is the temporal barrier. So different planting dates and hybrid maturities can also be used to reduce the risk of cross-pollination between fields of GMO and non-GMO corn. And the differences in maturity are usually may not be large enough to ensure that the flowering periods will not overlap. That's the only downside, is especially under certain climatic conditions. If we have a really hot, dry pollination period, or it's really cold or wet, it can throw the normal accumulation of GDs off. So you might have an early and a late hybrid. You're expecting them to differ by maybe several hundred GDUs or heat units, but because of the growing conditions, they overlap. The pollen is synchronized in such a way that you start getting some contamination. And this is only going to work if you control the adjacent field. So this gets back to the monitoring issue. This will only work if you can closely coordinate your corn planting operations with those of your neighbors. Of course, then there's the wind issue. We talked about this in Colorado. Out in the western states, this is a big issue. But you get up to northwest Ohio, and we have a lot of windy days. I remember a couple years ago when we had those derechos that came through in northwest Ohio. We had them in like 3 years in a row. We had those 70-mile-an-hour winds that came across the state. And 70 mile an hour is a blow pollen a long ways. So I'm not trying to present a negative picture here. But, you know, prevailing winds typically are from the southwest to the northeast during the summer. So there may be some rationale for, you know, looking at this or placing your fields to take this into consideration. So fields that are, the potential for pollen drift may be greater for fields in southwest of non-GMO fields. But of course, as I was saying before about the strong winds in northern Ohio or northwest Ohio, on any given day, winds can be from any direction. And that's why we're looking at using these production practices in combination with one another. So they're not, any one of these practices by themselves, it may not work entirely the way you wanted it to, but if you have several other practices in conjunction with it, it's going to be it'll present a greater means of preventing pollen contamination from occurring. One that I find kind of interesting, it doesn't seem to get that much attention, is the pollen blocking technologies. And by pollen blocking, I'm talking about preventing pollen contamination. And this can be used to prevent, basically slow the development of pollen tubes. There's two products out, well, there's two systems out there right now. The one that's commercialized is called Pure Maize. And it blocks incoming pollen from other corn to prevent cross-pollination. And basically, probably the word impedes would be better. It involves a pollen blocking factor that can be bred into conventional hybrids, and it has been. Hogemeyer Seeds in Nebraska did this a number of years ago, and the organic companies have picked this up. So there's about 6 or 7 organic seed companies out there. They grow the corn organically. And several of these companies have these pure maize corn hybrids available for growers. I don't know anything about them. I've never tested them. I don't know if the pure maize trait has an impact on yield, you know, if there's a yield drag factor or not. I've talked to organic farmers, and they claim that it works, but it's not something that I hear widely used. Again, if there are organic folks here in the audience, I'd ask you if you'd tried it, but I haven't. Again, I don't have any first-hand experience with it. The other one here is one that still is available, but nobody's commercialized it. It's the Teosinte crossing barrier. So what's going on, and just to show you that the pure maize works, this is from Albert Lee. It's an organic company, and what they did is they've got, on the left there, you've got a pure maize hybrid. On the right, you've got a regular yellow den hybrid. And both were pollinated with Hopi blue corn pollen. It's an open pollinated corn, produces a lot of pollen. You can see the hybrid on the right was contaminated. You see all those blue kernels. And the one next to it, pure maize. Supposedly, pure maize can be grown adjacent to a GMO corn and not be contaminated. Now, they do say in their literature there's some leakage can occur, but they don't really elaborate on that. So what's going on with the pure maize corn? Well, what happens with the pure maize is we're looking at here is an ovule in a corn plant on a corn ear. We'd have normally at the end of the season, we'll have about 600 or 700, maybe 500 to 600 with our population kernels of corn. At pollination, we have these ovules, and we have a pollen tube, the silks. The foreign pollen from maybe a GMO field lands on those silks of a pure maize silks, and they start to grow. They're not blocked. They start to grow, but they grow very, very slowly. And then the pollen from the pure maize plant falls on the silks, and it grows normally. And it grows, and it reaches the ovule to form an embryo and to form a kernel before the foreign pollen does. So that's how this system works. It basically impedes the development of foreign pollen. Well, I'm going to close to just mention when you want to check your corn coming out of the field, there's different types of testing for transgenic crops or for corn. There's strip testing, the dip test. It's the cheapest one, followed by the bioassays, where for herbicide resistance, ELISA testing, PCR. These are all, I'm showing them in order of cost. The simplest one is the Dipstick at the top, and I'm sure some of you have seen this one, or maybe you've seen it demonstrated. I've got the one on the left is for BT corn, and the one on the right is for Roundup Ready corn. And the procedure is if you grind up those, or you grind up some plant extract, and then you dip one of these sticks in it, and it'll tell you whether the presence of that transgenic trait. It's qualitative. It's going to tell you it's there. It won't tell you anything about the amount of it. But this is the only problem with this also is that you're going to have to get a stick that's specific for each one of those traits. So in summary, following current guidelines, cross-pollination in grain production fields can be limited to 1% or less. But it's difficult to produce grain levels less than 0.5% consistently using the current methods. Planting operations to control pollen drift are only part of the process of producing an IP crop. You know, there's other things that are very important that are kind of beyond the scope of what I'm going to talk about, but I'll just briefly mention that you need to follow hygiene practices when planting seed, harvesting, and handling and transporting the grain. You need to identify and eliminate all opportunities for seed and grain mixing, what the industry calls commingling. And then you want to follow that principle of first in the field and first out of the field. Fifth and fourth. Plant and harvest the non-GMO hybrids first. We've got a handout. There's a fact sheet on this information that I presented today. I'd say some of the information I went over today is a little more recent, and there's a lot of good information on the web. You can Google it. That's on pollen drift management. But this is a starting point if you want to take a look at that fact sheet. I have some references for information from other states. Thank you.